Okay, Professor Lohman, hi. This is test 5, problem 9. We'll start with part A. Okay. So I'll read the question. And okay, you pull a crate using a rope as in figure 1, except the rope is at an angle of 20 degrees. So do this. Rope is at an angle 20 degrees. Okay, T, tension of the rope. Okay, above the horizontal. The weight of the crate is 245 newtons, so weight. Okay, the coefficient of kinetic friction between the crate and the floor is 0.25. What must be the tension in the rope to make the crate move at a constant velocity? Okay, so we know there's a normal force, there's weight, and we know that there's friction. So we'll put friction. So we're going to solve for T. We're going to do F forces of X going to be equal to negative friction plus T cosine 20 equals 0. Okay, and then we'll have Fy. We'll have N minus W plus T sine 20 equals 0. We'll solve for the normal force because we know that friction equals nu normal. So we'll solve for the normal. Normal equals the weight minus T sine 20. Now we'll put that into the F of X, forces of X equation for friction, and it's 0.25 because that's lambda, that's nu, sorry. And we do times W times T sine 20. And that is equal to, we'll do minus T cosine 20. So we'll do some math for this. We can do negative 0.25 times 20. We can add that to the other side. So it's 0.25 W equals, then we can take out the T and do cosine 20 plus 0.25 sine 20. Okay, then we solve for T. That equals 0.25, and we'll plug in the value for weight, which is 245, all over cosine 20 plus 0.25 sine 20. Okay, I'll plug that into the calculator, see what the answer is. Okay, I got 59.7. And that's the correct answer. So now we'll go to part B. What is the normal force that the floor exerts on the crate? Okay, so we found that the normal force was equal to, let's do part B, normal equals W minus T sine 20. So we'll just put, the weight is equal to 245. We got T is equal to 59.7 sine 20, and that will equal the normal force. Let's plug it into the calculator and see what we get. We got 4.5 rounds to 25, and that's going to be in newtons. And the previous question was also in newtons. Can't forget that. Okay, then we go to part C. Okay, you pull on a large box using a rope as in figure 1, except the rope is at an angle 15 below the horizontal. The weight of the box is 245 newtons, and the coefficient of kinetic friction between the box and the floor is 0.25. What must the tension in the rope be to make the box move at a constant velocity? Okay, so this is like the last problem we did. So we'll get the forces of X. Actually, we'll draw out a free body diagram. So we have the weight, we have normal, and we have tension. This is going to be 15 below the horizontal. Then we have friction. Okay, so we're going to get the forces X, which is just going to be it's going to be T cosine 15 minus F equals 0. Get the forces Y equals N minus W minus T sine 15 equals 0. Okay, we know that the friction is equal to nu times normal. So we'll solve for normal. Normal equals positive W. Equals W plus T sine 15. We'll plug that into the equation. We'll start working with Q now. We'll do negative W plus T sine 15. Actually, it's 0.25. Negative 0.25. And then T cosine 15. Okay. So we can move the negative 0.25 W to the other side because we're solving for T. So we do that. Then we get negative 0.25. We can take the T out. So we could be sine 15 equals cosine 15 t, we can solve for t equals 0.25. We'll plug in the weight, what are 245, 5 newtons, divided by cosine 15 minus 0.25 sine 15. Put that into the calculator and see what we get. Okay, we got 67.96, 67.96 newtons. That's correct, rounds to 98. Okay, we go to part D. What is the normal force that the floor exerts on the box? Okay, we know that normal equals W plus T sine 15. So we know 245 plus 68 sine 15. And we get the normal is equal to, plug that into the calculator, 245 plus 68 times sine 15, 262.6, which rounds to 63. Okay, now we'll go to part E. Okay, part E. You are using a lightweight rope to pull a sled along the level ground. The sled weighs 45 newtons. The coefficient of kinetic friction between the sled and the ground is 0.2. The rope is at an angle of 12 above the horizontal, and you pull on the rope with a force of 125. Find the normal force that the ground exerts on the sled. Okay, we'll draw a free body diagram. So sled being pulled at a tension 12 degrees out from the horizon. It's going to have a normal force. It's going to have weight. And there's friction. Okay. So we know that normal equals W minus the component from the tension. It's going to be subtracting from the weight. So it's going to be T sine 12. Okay, and then we just plug in the numbers. 125 is the, oh I know, that's 125 is the tension of the rope, sine 12, and the weight is going to be 485. Plug that into the calculator. got 459 newtons. Okay, now we'll go to part F. Okay, find the acceleration of the sled. Is the sled speeding up or slowing down? Okay, so we can find the acceleration with we'll do F equals ma, and we need to find the mass first. So we have the weight of the sled in newtons. We have the force 485, and we have the acceleration, which is 9.8, and that will equal the mass. Put that in the calculator. 485 divided by 9.8 is equal to 49.4898. Okay. Then we have the weight. Well, we'll find the force. No, we'll find the force for the sled moving. So we have force of X is equal to the tension of the rope cosine 12 minus the friction, which we know friction is nu normal. Okay, so we'll plug in nu. We know we'll plug in the numbers now, and we'll solve for this equation. We know that T is equal to 125 go minus nu is equal to 0.2. And we're going to multiply it by, we found what the normal force was in the last problem, which is W minus T 125 sine 12. Okay. And we'll plug that into the calculator. Oh, and the weight. Okay, Professor Lohman, we're back. The video cut out a little bit because it was too long. So here we go. We're going to finish up. And as we can see, we got 30.46 over 49.46. We took the force, which was equal to 30.46, and we divided by the mass. We got an acceleration equal to 0.615. The answer is 0.62, which is just rounded. So now we'll finish off with part G. Okay. Let's read the question. Okay. A large box of mass M sits on a horizontal floor. You attach a lightweight rope to the box. Hold the rope at an angle theta above the horizontal and pull. You find that the minimum tension you can apply to the rope in order to make the box start moving is T-min. Find the coefficient of static friction between the floor and the box. Okay, let's draw a picture. Okay, G. Okay, a large box of mass M sits on a horizontal floor. So So we have tension and theta, T min. We have friction, we have normal, and we have weight. Okay. And we're looking for the coefficient for static friction. So if we solve for Fx, we'll have T cosine theta minus friction, which is equal to nu normal. So we'll have nu, and we'll find the normal in a second. We have Fy equal to normal plus T sine theta minus W equals 0. So we can solve for the normal, which is just going to be W minus T sine theta. Now we're solving for nu, so we'll move it to the other side. T cosine theta equals nu, and we'll replace W with mg minus T sine theta. So we'll have nu equal to T cosine T min cosine theta over mg minus T sine theta. Okay. And as you can see, that is the answer. T min cosine theta over mg minus T sine theta. T min sine theta. And that's all. Thank you for listening. Have a nice day, Professor.